Hi, everyone. In this video, we would like to talk about paper-woven circuits, the fabrication approach for papercraft-based electronic devices. In this work, we investigate an approach to integrate electronics into a paper-based structure. Specifically, we focused on paper-woven crafts. Paper weaving is a technique to create various shapes using strips of paper. These were originally made using leaves such as palm, grass, and sage. Recently, woven crafts have become popular because they can be made from common paper materials. The weave structure made of paper is durable, lightweight, and can keep its shape, thus, additional wireframe assembly is not necessary. This video shows the over and under weaving. While there are several ways to assemble paper strips, over and under weaving is one of the simplest methods. This weaving method can be used to create various shapes based on a boxy or a cylinder shape. The over and under weaving is easy to learn. But designing an arbitrarily sized and shaped object without using a ready-made layout is difficult. It is necessary to consider the length of the strips to be cut and a number of rows to match the shape. For this, Igarashi proposed Bandweavy, an interactive design system for paper-woven crafts. The Bandweavy system computes the length and width of each strip to satisfy the requirements. If we can add interactive elements to the original paper-woven artwork, a greater variety of expressions will be possible. Researchers have developed fabrication techniques to integrate interactive elements into substrates based on thin and flexible materials such as paper. In these techniques, circuits, sensors, and wiring are implemented by the printing or pasting conductive materials such as silver nanoparticle ink, copper foil tape, and gold foil on paper substrates. Based on these techniques, researchers have also investigated the integration of interactive elements into paper-based structures, such as origami and kirigami. The origami and kirigami structures can be moved dynamically to achieve tangible interactions. In these works, the sensing circuits are added to sense such interactions. We take a different approach inspired by the method of weaving passive strips to form various shapes. The key idea of paper-woven circuits is to add wiring and sensors to the papercraft by adding conductive materials on the surface of the strips. By weaving the strips together, it is possible to simultaneously form the skeleton of an object and its wiring or sensor arrangement. Our approach includes a set of fabrication techniques and a design support system. Firstly, let me describe the fabrication workflow. The fabrication workflow consists of 4 steps. First, the user uses the design support system to determine the shape and size of the object. Then the system shows the generated 3D model. The system previews the 3D model in real time while editing the object interactively. These functions are implemented based on the Bandweavy system. We additionally implemented the functionality to embed interactive elements. Once the shape is determined, the user selects the interactive elements to apply, then adjusts the positions on the surface. This function generates conductive patterns for wires and electrodes to implement interactive elements at specified locations on the bottom or side of the object. When the user clicks on the export button, the fabrication file will be output. The fabrication file contains the outline of the paper strips and conductive patterns. In the second step, the user prepares the conductive pattern based on the generated fabrication file. The user can prepare conductive patterns by printing silver nanoparticle ink with an inkjet printer or patterning metal foil with a cutting plotter or laser printer. Next, the user prepares the strips by cutting the papers with a cutting plotter or scissors. Finally, the user assembles the object by weaving the paper strips and attaching the electrical components. In this example, the touch sensing circuit is attached inside the lampshade. Here, I'll briefly introduce the several applications of paper-woven circuits. It shows the animation box application with an LED matrix. Here, we chose a box shape as the base shape, and selected the interactive elements of the display. All LED chips work by simply attaching to the intersection of the woven paper strips, because the conductive patterns on vertical and horizontal strips are exposed on the surface. It is a smartphone cover with a touchpad on the backside. We chose a box as a base shape, and selected the interactive elements of touch sensing. The touch panel can be extended and operated from its back by attaching the end of the conductive pattern to the smartphone's front screen. It shows a power supply mat for tangible objects with passive components. We chose a flat plate as the base shape and selected the power supply's interactive element. One strip group is connected to a power supply, and the other is connected to the ground. When the user places the tangibles on the mat, the passive components such as LEDs or DC motors can be powered. We also create papercraft type tangibles with a bridge circuit is embedded. This example has a clip-shaped connector, and when the user inserts it into the intersection of woven strips, the LEDs are powered. This is an interactive lampshade. We chose a cylinder as the base shape, and selected the interactive element of touch and proximity. 3 vertical strips have a conductive pattern of gold leaf, and are connected to a touch sensing circuit. When the user swipes on the lampshade surface, the lamp's brightness can be adjusted. This shows an application for sound amplification. The user can integrate an electrostatic loudspeaker into the weaving structure by alternating conductive and insulating layers. The woven strips with a conductive layer vibrate to generate sound by applying a high-voltage audio signal. Next, I briefly discuss the limitation of our approach in future work. The current design system supports only basic shapes. But supporting a wider variety of shapes is an important next step. For example, in the smartphone cover application, the design incorporating an opening for the camera part is desirable. It is also preferable to allow the user to use an arbitrary 3D model in addition to the preset basic shapes. We plan to use orthogonal 2-layered weaving principal strips to create freeform objects. The circuits used in our applications were simple, but the assembly required at least basic electronics knowledge, such as the polarity of electronic components and bridge circuits. We are planning to add a function to support the assembly of electronic circuits, so that users with little knowledge of electronics can use the approach. We plan to hold a workshop where participants create artworks using our approach. This function will be necessary. Finally, all the fabrication files of the applications are embedded as vector data in the PDF of our paper. Let me conclude. In this work, we proposed an approach for integrating electronic devices into a paper-woven structure. We implemented a design support system to support users in designing a paper-woven craft with embedded functional layers. We also introduced example applications demonstrating how our approach generates new expressive possibilities. Thank you for listening.